The Inelastic Collision Simulation is an interactive educational tool designed to help students investigate and understand the principles of inelastic collisions in two dimensions. By providing a hands on approach to exploring the dynamics of inelastic collisions, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics. The simulation allows students to interact with up to two objects, enabling them to observe and analyze the outcomes of various inelastic collision scenarios. Inelastic collisions are those in which some of the kinetic energy of the system is converted into other forms of energy, such as heat, sound, or deformation of the objects. Unlike elastic collisions, where the total kinetic energy is conserved, inelastic collisions result in a loss of kinetic energy. This makes them particularly interesting to study, as they reflect real-world scenarios where energy is not perfectly conserved. The Inelastic Collision Simulation provides an interactive platform where students can actively engage with the concept of inelastic collisions. By manipulating the parameters of the objects, such as mass, velocity, and angle of impact, students can observe the outcomes of different inelastic collision scenarios. This hands-on approach helps students gain a deeper understanding of the principles governing inelastic collisions. The simulation allows students to investigate collisions involving up to two objects. This feature enables students to explore a range of inelastic collision scenarios, from simple head-on collisions to more complex glancing collisions. By observing the behavior of two objects, students can gain insights into the dynamics of inelastic collisions and the conservation laws that govern them. Students can adjust various parameters of the objects, including mass, velocity, and angle of impact. This flexibility allows students to create and analyze different inelastic collision scenarios. For example, they can observe how changing the mass of one object affects the outcome of a collision, or how altering the angle of impact influences the trajectories of the objects. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the movement of the objects and the outcomes of the inelastic collisions in real time. This visual representation helps students grasp complex ideas more easily and understand the principles of inelastic collisions in a more intuitive way. One of the fundamental principles explored in the simulation is the conservation of momentum. According to this law, the total momentum of a system before an inelastic collision is equal to the total momentum of the system after the collision. By observing the outcomes of different inelastic collision scenarios, students can verify the conservation of momentum and understand its significance in the dynamics of inelastic collisions. The simulation also allows students to explore the loss of kinetic energy in inelastic collisions. Unlike elastic collisions, where the total kinetic energy is conserved, inelastic collisions result in a loss of kinetic energy. Students can observe how the kinetic energy is redistributed among the objects after a collision and understand the role of energy dissipation in the dynamics of inelastic collisions. Perfectly inelastic collisions are those in which the two objects stick together after the collision. In the simulation, students can observe perfectly inelastic collisions and analyze the outcomes. By adjusting the parameters of the objects, students can explore how the conservation of momentum and the loss of kinetic energy affect the trajectories of the objects after the collision. Partially inelastic collisions are those in which some of the kinetic energy is lost, but the objects do not stick together. The simulation allows students to explore partially inelastic collisions by introducing energy loss mechanisms. By observing the outcomes of partially inelastic collisions, students can understand the role of energy dissipation in the dynamics of collisions. The principles of inelastic collisions have numerous real-world applications, from understanding the behavior of particles in physics to designing safety features in vehicles. By exploring inelastic collisions in the simulation, students can gain insights into the practical applications of inelastic collision principles and understand their relevance in various fields. The simulation encourages students to develop problem-solving skills by analyzing different inelastic collision scenarios. By adjusting the parameters of the objects and observing the outcomes, students can practice critical thinking and analytical skills. This hands-on approach helps students build a strong foundation in physics and prepares them for more advanced studies. The simulation provides an interactive platform where students can actively engage with the concept of inelastic collisions. By manipulating the parameters of the objects and observing the outcomes, students can gain a deeper understanding of the principles governing inelastic collisions. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the movement of the objects and the outcomes of the inelastic collisions in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to inelastic collisions, including conservation laws, perfectly and partially inelastic collisions, and real-world applications. This comprehensive approach helps students gain a holistic understanding of the dynamics of inelastic collisions and their applications in various fields. The inelastic collision simulation is a valuable tool for teaching and learning about the principles of inelastic collisions in 2 dimensions. By providing an interactive, visual, and comprehensive platform, it helps students understand the fundamental concepts of inelastic collisions, including the conservation of momentum, the loss of kinetic energy, and the dynamics of perfectly and partially inelastic collisions. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of inelastic collisions and their applications in various scientific and engineering fields.